Welcome to the Geometry Final Review. This is Standard 6. I think it'll all be on one video. I just want to remind you that the right triangle trigonometry has 2 or 3 videos already made for it. They're actually pretty decent. If you look on my channel, my YouTube channel site, you will find that if you tell it to sort my videos by most viewed, that those will be the ones that come up toward the top. It's like right triangle trigonometry how to. So for those, I'm just going to show you, I've worked out the problems. I'm just going to basically put them in front of the screen for a minute so that you can see and use them to check with. I'm going to focus mainly on using the law of sines and cosines. I can't remember if I've done a video on that, so that's where we're going to spend our time on this part of the review. Okay, there's your first one. Remember that in any methodology we use, we pick the angle. Only one we could use this time, really. Well, I guess we could use that one if we solve for it. Label our sides based on that angle. This is the opposite, the adjacent, and the hypotenuse. Pick our formula based on what we know and what we want. And so this one had 2 different ones. We needed to find the adjacent and the opposite, but we can only find one at a time. So we used 2 different functions, and we found the 2 values, 6.30 and about 4.93 for y. Looks like they're out of order, I'm sorry. Here is the next one. It is, I used sine on it. Got an answer of 5.19. The next one. Remember that when we're trying to find the angle, we use the inverse functions, but we still use the sides. For example, here the 2 sides that I know are the opposite and the hypotenuse. I happen to know those always go with sine, and so I use the sine inverse, opposite of the hypotenuse, plugged in my numbers, and I got this. Remember, this is really easy. Just plug that into the calculator and it'll tell you what it is. Okay, when we're using the law of sines and cosines, the first step, just like on a right triangle problem, is to label our sides. And we learned that the way that we label our sides is we always label them with the letter that's the angle opposite them. Like here is angle A, the side across from it will be little a. Here's B, the side across from it will be little b. And the side across from Z will be a little z. Now, we need that most of the time. If they don't tell you, you can label them with any letters you want, but they have to be across from each other. They have to be the same. Just won't work. Okay. When do we use the law of sines and cosines? We can use them on any triangle, but we typically use them on things that are not right triangles. The law of sines, I'm going to make it a little bigger, usually is used when you know an angle and you know the side across from it, but maybe you don't know any other information. You don't know, you don't know any more than one other piece of information, like you might know a side or an angle. Okay? The law of cosines, on the other hand, is used when you when you know an angle and the 2 adjacent sides. When you know that, then you're ready to use the law of cosines on that one. Now, I forgot to write these out, so I'm going to write them out real quick. This would be a good one to have in your notes, but I'm going to use a shortened form of it. The law of sines, just one form of it, is the sine of an angle and the side over the side across from it will equal the sine of an angle and the side across from it. That's the law of sines. The law of cosines, there are 3 of them, and I'm only going to give you one. If I'm trying to find side A, then A squared equals the square of the other 2 sides added minus 2 times the other 2 sides times the cosine of the angle that matches the side you're looking for. Okay, so those are there. Let's see what kind of problems we have now. Okay, now it says to solve for x, looks like I know an angle and the side across from it. So that looks like a good candidate for the law of sines. So I'm going to write it down. The sine of 19 degrees over 16 should equal the sine of 40 degrees over x. Okay, you can change these into numbers, and in this case I probably am. Let's see, the sine, I've already checked the mode on my calculator. The sine of 19 degrees is 0.3256. The sine of 40 degrees is about 0.6428. So I'll use those values instead of those two. Cross multiply, I'll get 0.3256x equals 16 times 0.6428 is about 10.2848. Now I'm going to divide both sides by 0.3256. Okay. And I get that x is about 31.59. Okay, there's the rest of the problem so you can see it. Okay, law of sines. Angle across from it. Another piece of information. I'm trying to find the angle across from it. Remember that in triangles like this, you could have found this angle if you needed to. Okay, here's another one. Let's see. I know this angle. Don't know that side. Know that side, but not that side. This looks like another law of sines problem to me because I know this angle and that side across from it. So I'm going to say the sine of 40 degrees over 5 equals the sine of 60 degrees over x. Let's find out what sine 40 and sine 60 are. Sine 40 we already know. It's 0.6428 from the previous problem. Now let's see, sine of 60 degrees, 0.8660. Okay, cross multiply, 0.6428x, that's that one, equals those two times. And that gives me 4.33. Now I'm going to divide both sides by 0.6428. I get 1x on this side equals, or is about equal to, 6.74. So I know that x is going to be 6.74. And I hope that helps. I don't have an example of the law of cosines from your review sheet, so I did want you to see it. But and we did go over one in class. Anyway, good luck.